Okay guys, so we are getting into rocks and minerals, and we're going to start off with learning about what a mineral is and what we do to identify minerals. So just a reminder, don't forget you can press pause on this video at any time so that if you need to write anything down, you're not going to fall behind or miss anything that I say. So to start off, what is a mineral? Well, a mineral is a naturally occurring inorganic solid that has a crystal structure and a definite chemical composition. Okay, again, you might want to pause that. All right, so what is naturally occurring? Naturally occurring means that a mineral has to be found on the Earth's surface or dug up out of the crust. It is not made in a lab. It's not made by people. So an example of man-made objects are bricks, cements, glass, plastic bottles, pens, anything like that. So that it has to be naturally occurring. Next, it has to be inorganic. This means that they do not come from living things. So if inorganic means it does not come from living things, then organic is living thing. It comes from a living thing. So coal forms naturally in the crust, and it comes from living things. So coal is not a mineral. Also, wood is not a mineral. It is organic. It comes from a living thing, a plant. Inorganic means not living. So a mineral has to be inorganic. It also has to be a solid, and solids are substances that have a definite shape and a definite volume. So if it's a liquid or a gas, it's not a solid. The particles also for a solid are very tightly packed together. Okay, next, a crystal structure. That means that the atoms of that mineral are connected and they form a pattern. And this pattern is called a crystal structure. So the flat sides form faces. Halite, which is salt, has a crystal structure, and its crystal structure is in the shape of a cube. Okay, a definite chemical composition. That means that there's a specific chemical formula for each mineral. The mineral pyrite, which is also known as fool's gold, is made up of 1 atom of iron for every 2 atoms of sulfur. So FeS2 is always going to be pyrite. Pyrite will always have the same chemical formation regardless of where it is. That never changes. All right, so you're digging up stuff in your backyard or somewhere, and you found some what look like rocks, but you know they're minerals, but you don't know what type of mineral that each one is. So we have ways of trying to identify minerals. You can't really just look at a mineral all the time and know what it is. Each mineral has its own characteristics of properties that help you to identify them. So the first one is hardness. Hardness is one of the best clues to identifying mineral. So we have what's called the Mohs hardness scale, and it goes from 1 to 10. And if you look off to the side, you'll see they give an example for 1 is talc. Talc is actually a very powdery-like mineral. It's used in chalk. It's also used in girls' makeups, like the powdery foundation you put on your face. And then it goes all the way up to 10, 10 being the hardest. And as we know, or if you don't know, you know now, diamonds are one of the hardest minerals. So we'll be working with the hardness of minerals. If a mineral scratches easy, then it's soft. We also look at color, and color is a physical property that's easily observed just by looking at it. However, not many minerals have distinct colors. Malachite is always green. It does have a distinct color, and azurite is always blue, and it has a distinct color. But sometimes a mineral's color can kind of change. So it's not always a really good way of identifying minerals. but along with the other steps, it's very helpful. Okay, now we have streak. The streak of a mineral refers to the color of the mineral's powder. And what you do is you just take the mineral and you scrape it across a piece of an unglazed piece of tile. And usually there's two main colors. It's kind of like maybe a reddish brownish streak, or sometimes you'll get like a white streak. The streak of a mineral is always the same. So a diamond will always have the same streak. Pyrite will always have the same streak. Hematite, which is in the picture, will always have the same color streak. That does not change. And the streak is not always the same color as the mineral itself. Luster. Luster has to do with how shiny a mineral is. Luster refers to how a mineral reflects light. Metals are often shiny. Other minerals may be glassy, waxy, or kind of pearly. So kind of the reflection, the shininess of a mineral. So some minerals are very dull looking, so they have no luster to it. Some minerals are very shiny and do have a luster to it. Okay, this is just an example of two different minerals. Notice that these minerals have a very high luster because they're very shiny and they reflect the light off of them. Okay, next we have identifying minerals is density. Density of a mineral is always the same. It never changes. And it deals with like the heaviness of an object. Density refers to how tightly packed matter is within an object. So for example, if you had a baseball and a tennis ball next to each other, they're pretty much the same size, but if you held them, you would notice one is heavier than the other, and that's because it's much more dense. All the matter within it is much more tightly packed together in a baseball than in a tennis ball. Tennis ball actually is hollow on the inside. Okay, a crystal structure. Each mineral has a crystal structure, and there are 6 groups based on the number and the angle. You are not going to be expected to know these 6 different groups. You just need to know that a mineral does have a distinct crystal structure. If a crystal grows in an open surface, it produces perfectly shaped crystals. However, if it grows in a tight space, the crystals are often incomplete. So we won't be necessarily using this whenever we're trying to identify minerals. Okay, how a mineral breaks. Minerals usually break in a very distinct way, and it can also help you to identify that type of mineral. If it splits easily along flat surfaces, it has a property that's called cleavage. If it does not break evenly, it has a characteristic that's called fracture. Okay, so if you notice the calcite above, it has very distinct flat surfaces on it, and that's called cleavage. And then below the copper, you notice that there's no distinct flat surfaces on it, and it's just a fracture. This is just a picture showing different types of cleavage. So a mineral called muscovite has a cleavage that's just in one direction. In fact, if you were holding muscovite and you just kind of peeled it away, it's almost like peeling off sheets of paper. And then feldspar has a cleavage that's in 2 different directions. Calcite has a cleavage in 3 different directions. And we won't be getting into identifying and having to know the names of all the different types of names for the cleavage based on the directions that they break, but you should be familiar with some of it. Okay, so how do minerals form? They form in 2 ways: through the crystallization of melted materials and through the crystallization of materials dissolved in water. Magma that cools at a slow rate will produce large crystals, while magma or lava that cools rapidly will produce small crystals. Okay, so mineral uses. We use minerals every day, and you might be surprised at what might or might not be a mineral. So minerals are the sources of metals, gemstones, and other materials used to make products. Obviously, gemstones, they're hard, they're colorful, we use them in jewelry. A lot of gemstones can be very valuable. And once they're cut, it's referred to as a gem. Metals are useful because they can be stretched into wire or hammered into sheets. Metals are used in making tools, framing buildings. Even the filaments in the light bulbs are made from metal. And then some other uses, if you've ever been told that you need to get your vitamins and minerals, or that some cereal has vitamins and minerals, well, those are minerals found in the earth, and our body needs some of those minerals. So you find minerals in food, we have minerals in medicines, fertilizers, and other building materials. Okay guys, so that's the end. Oops, hold on here. This is minerals. Again, if you did not get all the information, then you can go through this video again, because you did have some questions that you had to answer, and I will be collecting those questions to make sure that you got the information that you needed from this. So go through it again if needed, or if you also have any questions, then you can see me. So have a good night, and we will see you later.